In this recording, I'm going to talk about formally verified credential management systems for industrial control systems, a research paper submitted to Formalized 2021, where we have worked on providing a secure credential flow for industrial control systems. So let's get into it. Let's start with an overview. So at first I would like to introduce some challenges of industrial control systems, especially when it comes to security. Then I will talk about the contribution of this work. Then I will discuss the integrated credential management. We'll demonstrate the credential flow protocol, or what is the protocol that we use within this setting. Go through a formalization, so show how we have formalized different aspects of the system and also some of the security properties. Then show how we have carried out formal analysis in UPPAAL, discuss results of this analysis, and then conclude, plus discuss some of the future plans that we have for this work. So, what are some challenges of industrial control systems? So, in nowadays, or in modern systems are often very interconnected. So it's not isolated PLCs, for example, or isolated controllers, but there is a lot of connectivity going on. They are very distributed, so the control is the parts of the logic of the control is distributed among the different systems, and the physical control, so some control of physical process, depends on digital subsystems. Now this of course leads to some challenges, so we need to consider the safety of this system, of course performance, and security. We can also say that very often safety could be a function of security, and we need to make sure that our system is secure, and security and performance are sometimes pitted against each other, and they need to form some sort of a trade-off. Now let's look into the contribution of this work. So here we have presented created a credential management system. Now for this we have created a credential flow protocol. Now we have formalized the system and carried out the formal analysis of the credential flow protocol. So how does this actually look like, and how does a system that we are basing this on look like? So this is an architecture that we have developed together. It's very simplified. We have developed this together with an industrial partner that is actually currently working on building some of the aspects of this presented work into an actual commercial system. So let's say that we have a component called a key vault. Now this component is a component responsible for knowing who has access where, or it contains the database of valid users, and it is also the component that actually understands the state of the flow, or where the credential flow is at the moment. This is by issuing tokens, access tokens, and access tickets that we get into a little bit later. Then there is an OT, which is a short for an operation terminal. The operation terminal is what the user would use to actually interact with the system. So in this situation, let's say that the user wants to log into the system, so comes to the OT, provides some credentials, the key vault checks these credentials, generates a token, and if the user then wants to go and log into the switch to do some kind of network editing, all different kind of things, then based on the rights on this token, the key vault could issue an access ticket that could be then utilized for connectivity to the switch. So switch. What is it? It's a we could see it as a standard network switch, sort of a managed switch here that interconnects a lot of controllers or microcontrollers underneath. So very often, as the systems are being retasked, the network connectivity, topology, and things like that need to change as well, and this leads to the need of the user to interact with the actual switch. The controllers here, they are mostly abstracted away from our work, as we are primarily dealing with the management of the switches, but nevertheless they need to be shown here, as this is where the control actually happens, and switches are more or less a communication management devices. Now, let's see what are some of the different steps. So at first, we would like to log in towards the switch. As I have mentioned before, we would like to also have some kind of a single sign-on. So if you log in once, the system already knows, okay, could you go onto this switch or not? Now, we would like to also have some redundancy in the system. So initially, could see that we have two key vault components, and these key vault components both have the necessary information to actually carry out these logins, and they need to also synchronize one with another. And this is what we have analyzed using model checking. Specifically, we have expressed this in UPPAAL and analyzed it using a UPPAAL model checker. So let's get more into that. So what is this actually based on? So we have been looking on, could we utilize some protocols that are currently in existence for some work like this? So specifically, we have looked at OAuth 2 based for the top login. So the top login is a where the user just logs in towards the operating terminal, and from there can start actually going onto the other devices, such as the network switches. So then for connecting to switches, we have looked into a protocol such as Radius that is used very often and actually supported by many network switches, managed switches. We have considered, okay, we would like that this work actually has potential for LDAP integration, and have a hardware device that is not a part, so it's not just a process running at the OT or something like that as an arbiter of this communication, or as this system authentication and authorization. Now, let's look into the credential flow protocol. So we try to base it on the standard protocols, again, OAuth 2 and Radius. Live with short-lived logins, right? So let's say you log in and then for a while you step away from the operating terminal. This login should not live much longer than that. So if there is some period of inactivity, you need to re-log in pretty much. And something that would require minimal user interaction. So we can see here that we have 3 times user input, initially logging in, then trying to log into the switch, and then of course updating some kind of parameters on the switch. The parameters here are abstract, as it could be anything really that could be updated on the switch. And we have our 3 components here: the operating terminal, the key vault, and the switch. And let's get into a bit more detail here. So there are 2 parts to this. Initially, this is the top part where the user logs in towards the operating terminal. So what happens? The user submits credentials to the key vault. The key vault can then validate this credential and decide, okay, if this is not valid, the access is denied, and we stop there. If this is indeed valid, then the key vault will create an access token and provide this to the user, where the user, as he logged in, already selected the switch, so this is provided with the token as well. And this token is then again validated by the key vault, and again, if the token is invalid, access will be denied. If it's actually a valid token, an access ticket to the switch will be created, sent to the user. The user now has the switch, now has the ticket that he actually needs to get onto the switch. So this was sort of OAuth 2 like flow, getting the token, and then once we get to the ticket part, that switches more to the radius flow, starting here. So with the possession of the ticket, the user can then at some point decide, okay, it's time to log in to this switch, and initiate the login with the access ticket. The switch then sends this ticket to the key vault in order to validate it, where the key vault is actually aware of this ticket. It can contain it has some expiry date, expiry time, it has some identity, so it could so the key vault knows that, okay, it was actually issued by the key vault. And then if this is not valid, the key vault informs the switch, and the switch returns this information to the user, to the OT. And this is because the OT is the device that actually has the screen or the user interface necessary for interaction. In case that this is valid, the switch will open its session and inform the user about the open session. So pretty much you would get the management screen of the switch now available. And this is where the user can update some kind of parameters. When this happens, the switch checks, okay, is this session still open? And if the session is still open, then it will pretty much update the parameters, and if not, again, it will inform user that the access is denied. In any case, if the session is not open anymore, the user needs to return up here to actually utilize the ticket. If the ticket is not valid anymore, the user needs to actually ask for another ticket. It could come from here, for example, from selecting the switch, but this could be synchronized, so the ticket stops its validity once the token stops its validity, meaning that the user needs to go all the way on top. So the second part here was run as a radius-like flow. Now, let's get a little bit into formalization. This is actually a quick overview of the table of all the actions that are present, and they are arranged by component. So we have some actions that are available for the operating terminal, some that are for key vault, and some that are for the switch. And this table presents how they actually synchronize with one another a little bit in the UPPAAL way of thinking synchronized actions. So login synchronizes with the get login on the key vault from the OT, synchronizes with the get login from the key vault. Validate credentials, for example, here we can see it's an internal action, so it does not really have synchronization with any other components. And here we can see that the key vault can send access denied, which eventually synchronizes with the access denied on the OT. And once again, creation of the token is an internal action. We have several of these actions here represent handling of tokens, so providing of the tokens, getting a switch request from the OT, and then validating the token, of course, that is passed with this request, and then creation of the ticket again. Then this ticket is sent to the OT again. And then we finally get to the interaction with the switch, where the ticket is actually transmitted to the switch, which checks it. The switch does this only with the key vault, as shown before. So all the access is negotiated with the key vault based on the access ticket. And once again, the things that the user knows pretty much is if the access was denied or if the access is actually valid. And it's only here where the switch actually finally interacts with the user. So how does a switch component look like? So we have a switch template that has some identity and a predefined session expiry time. So that's something that could be tweaked depending on how long-lived our sessions should be. We say that our switch should be unique, right? So every switch needs to carry its own unique identity. And this is how we can check for the session validity. So we always check, okay, is the session expiry time greater than the current time within the system? So the session is still valid. Now let's look at the key vault, which is another important component. So here our key vault template actually has some credentials database, so the database of users, their passwords, role database that is then mapped towards the credentials database, right? So a user can, for example, be just an admin user and things like that. Then we have something such as token expiry times, so how long our tokens should be valid for, ticket expiry times, and ACT stands for active. We have two key vaults and with a sort of active passive configuration. One of them would be active true, another one, the passive one, would be active false, and if one fails, the other one can take over. Now we generate tokens. So how our token looks something like this. We have some ID, some role in the token, issue time, and the expiry time. And the validity of tokens we check here. So let's say that we want to go further into the system, somebody that needs to have specific role. So we check, okay, is our token not expired, and is our role actually admin? Now we can validate tickets the same way. So we check that the tickets actually, are they still valid time-wise, and we check against a database of currently active tickets within the key vault. If the ticket is there, it's still valid. And we need to ensure the consistency with the secondary key vault. So both key vaults synchronize the currently issued or currently active tickets among themselves. So we have KVP as a primary and KVS as the secondary key vault. Now let's look into some security properties. So we have an authentication property where we simply state that the token that is that doesn't have a role of admin, and the issue time is it's lower than the current time, and the expiry time is actually less than current time. That means that we will not be able to get a ticket. So if we are expired and not admin, then we cannot actually get a ticket within the system. Then we can check for freshness. So here it's we check that, for example, our tokens are not expired, our tickets are not expired, and our sessions are not expired. How does this look like in UPPAAL? So this would be the timed automata for key vault. So we start from here, and we could see that the very first, at least what should be the very first thing is here. We get a login, which is a synchronized action from the OT, continue from there, and then we either have valid credentials, which would create a token, provide the token, again synchronizes with the OT, or we will get access denied, again on a channel access denied. So that's for logging in towards the OT or the initial allowed flow. Let's look onto the switch. Switch has something similar. So we start with the switch login. So user tries to log in, the switch sends a ticket to the validation to the key vault, and then we move on here. If the access is allowed, open the session. If not, then the access will be denied. So this will actually, this and this action will be synchronized with the OT again. Now, how is this expressed in C? So this is the token freshness. So once again, we just check, okay, is this token non-expired? And we do the same pretty much for the tickets as well that are issued within the system. Yeah, so one of the things here is that we could potentially synchronize tickets with tokens, right? So at the expiry time of tickets, the tokens will expire as well, and the entire process would have to start from the beginning. Or if not, there is also the possibility of having, if the user already has a token, can request new ticket as if this synchronization is not in place. So what are some of the results of this work? So the verification time was less than 1 minute, and we have analyzed this the freshness properties and the authentication properties using a UPPAAL model checker. Now we have reached around 1.4 gigabytes of memory consumption, and one thing that we have utilized within the model is a use of discrete time in order to be able to compare discrete timestamps, or pretty much get a discrete timestamp and then compare it with the flow of time. So for example, the token issue time would be assigned as a discrete timestamp, and the same would be for a token expiry time. Now for this we have also created a small time discretization process within UPPAAL that is run in parallel to the other processes. Now we have satisfied we have find the model that would satisfy the properties that we have expressed, and are currently working on implementing actual prototype, which is almost finished. It's a combined device with some of our previous work, so it's not specifically utilized only for credentials, but this is also something that the industrial partner that we are working with is starting to utilize within their system. Now, to conclude, of course, we can concur that the model checking is an effective tool in analyzing this type of problems. Integrated credential management is feasible, so we could actually build this utilizing single system for both a access to higher level systems such as the operating terminal, including the access to lower level systems such as the network switches within this system. And yeah, so one of the things that we would like to see also is that we want to consider more standard protocols in the future as well, not only for credential management, but also sort of a key exchange, so cryptographic key exchange management and things like that. So this is something that still is a little bit open. We have also abstracted some of the things from the OAuth and radius away, so a little more detail is necessary. This is sort of coming into play now into this in the implementation of a prototype device. Now, in the future, we would like to utilize a formal analysis, and it would be a runtime formal analysis on a prototype device. So let's say that we could capture the traffic that exists on or is facilitated by the switch, and then could run these network traces via a small formal model to see if any message exchange breaks some of the properties. And one thing that we are quite far off is combining the analysis with the cryptographic key management responsibilities of the key vault system. This is something that we have presented in the past. So in the end, we would like to have one unified device that could handle both credential and key management. And with that, I would like to thank you and ask for any questions.
Okay, so thanks, Tomasz, for this great talk, and perfectly on time also. So we have a few questions here in the chat. So the first one, actually several ones, are by Mohammed. So if you're here, Mohammed, you can actually ask it live. Otherwise, I will just read the first question. Are you here? Doesn't seem to be the case. No. Okay, so the first question is, how is the communication between OTKVU and SW cryptographically protected? So for example, from MITM attacks.
Yeah. Okay, so in this work, this was abstracted away. Specifically, this work is a continuation of a PKI cryptography work that we have done previously, but now we have focused primarily on the credential management. Here, we assume that the channels are encrypted, and we start most of the communication using a mutual authentication and then encryption based on TLS certificates.
Okay,
I hope that answers that.
Yes, I guess so. Mohammed, if you're there, you can still ask your question live, I would say. But otherwise, I will read also your second question. Let's read it. So the second question is, the freshness property with existential time is quite weak. So the question is, did you try some stronger freshness property?
No. If we tried, no, not yet. At least it is in the plan to look into something that will be more based on a range. So also considering issue time and all that, rather than just an expiry time. However, this has came sort of also from the requirements that our industrial partner had. So we how to put it, we try to follow closely with sort of how the system should look like.
Okay. So now, yeah, I think that's answers it mostly. Otherwise, we will see some activity in the chat. So I also had a question, which is also a little bit connected to the last question by Mohammed. So I read in your conclusion of your paper that your industrial partner has decided to use formal modeling and analysis when considering extensions to the system. So I really want, so since I'm also involved in this, I really want, with another industrial partner, I really wanted to know whether they are actually planning to do the formal model analysis themselves, or they will hire someone, and maybe not you, but typically it's not easy for them to apply formal methods and tools. Here we're talking UPPAAL, which is, time automata. It's not trivial. So
yes. So the research work that we are doing together with the industrial partner, and actually several industrial partners that we are also presenting the results with to, is also aimed at actually bringing the formal methods a little bit more into the industry. And they not only model checking, we have also utilized other things such as VDM, for example. But they, in this sense, actually, it is a combination of things. So they are within the industrial partner, and unfortunately, they wish not to be named, at least when it comes to our security work with them. The idea is to actually get better understanding of how formal methods could actually specifically be utilized within their domain and within their systems and all that. And that's why our work is sometimes a bit too targeted towards a specific platform or architecture that the industrial partner has. However, it has also this end goal to actually have them to take over at least some of the modeling when it comes to it, and help out in the analysis, with the goal of eventually having formal methods a part of the design and development process. And we are actually talking about the large company. I have that much I can say within the sort of industrial domain. So production really oriented, heavy industry.
It was quite ambitious, I would say.
Yeah,
that's nice, very nice. Okay, so we have just a few seconds, and if there's anyone who wants to discuss further, there will be a discussion room available where Tomasz will be directing to, and the others will probably join the next talk. So thanks for answering the questions, and thanks for your nice presentation.
Thank you.